David Agatha.
Good morning to all.
Good
Good
morning,
morning, sir.
David Agatha.
Very good morning. Very good morning, guys. Very good morning. Turn on the camera, please. Very good morning. Edric. No. Okay. So now what we were doing chemical bonding chapter, and in this we learn about the ionic bonding. Yesterday we learned about the ionic bonding. So I will extract this page for you guys. Okay. So can you see this page? Is it visible? 140 page number. Okay. So yesterday we learned that how the NaCl bond is formed. NaCl bond is formed by the cation and anion formation. Did you understand? Turn on your camera, everyone. Okay.
Sir,
So note, yes,
left side of the page, there's a D. Delete it.
left side of the page.
There is a D.
Give me a second. Not there.
I can see it.
Where you can see. It's okay. Leave it. Okay. So now so we'll read this.
Uh,
Yeah. Note that the sodium cation has 11 protons but 10 electrons. It has 8 electrons in the outermost shell. The sodium atom has attained noble configuration by losing an electron present in the outermost shell. Loss of electron leads to the formation of ionization. According to the octet, sodium atom can acquire stability by changing the sodium ion into Na+1. Okay. Now, what is the meaning of this ionization? This ionization is what is the meaning of ionization? We will read this. Ionization. So, ionization means formation of ion. Formation of ion. So how much energy it's needed to requires an energy to become ionization means for making Na into Na+1, how much energy is needed? So this will be 496 kilojoule mole inverse. This much energy is needed for making Na into Na plus. Got it, guys?
oh, what
Yes
is
or no?
what is KJMOL -1?
Kj is the energy, kilojoule, mole is basically the quantity. Quantity means if I will say a dozen banana. What does this mean?
12 bananas.
12 bananas. So in the same way, mole means like a dozen. Okay, mole means it's like a dozen. It's a specific basically it contains 1 mole is equals to 6.022 into 10 to the power 23 molecules or atoms. So it means that there's that much atoms needed 496 kilojoule to convert Na into Na+1. So it's basically the 11th term. So we will learn this in the 11th class. Okay. Now, chlorine atom having atomic number 17 has the electronic configuration 2, 8, 7. So it will be gaining an electron from sodium atom, which is 2, 8, 1. Okay. Both sodium and chloride ion combine together to form ionic bond and become solid chloride NaCl. Okay. So negatively charged ion, that this is called as anion, and the chlorine has 8 electrons in the outermost shell. Therefore, the stable configuration according to the octet rule, and the formation of chloride ion releases the 349 kilojoule mole of energy. Okay, it releases 349 kilojoule mole of energy. Since cation and anion formed are electrically charged, they are held together by a Coulombic force or electrostatic force. What is the electrostatic force? Electrostatic force is the force which is between cation and anion.
Right.
Okay.
The force is equal to K into big Q into small q divided by R square. That force you're talking about.
Yeah, electrostatic force of attraction which hold cation and anion together is also called as electrovalent bond or ionic bond. So you can see this, and note that the above structure shown above, such structure is called as Lewis dot structure. Okay, Lewis dot structure. If we compare the energy formation of sodium ion release in the formation of chloride ion, we note that the net difference is 147 kilojoule per mole. See, sodium needs 496 kilojoule per mole, and chlorine, when chlorine become when chlorine gain the electron, so it releases how much? 349 kilojoule 349 kilojoule mole inverse. So to become chlorine minus 1. So the net difference of them is 147 kilojoule mole inverse. Did you understand? So it means that for making sodium into Na plus, he needs 147 kilojoule per mole inverse from outside. Okay. So if only these two steps are involved, the formation of sodium and chloride ion is not favorable energetically. But sodium chloride exists crystalline solid. So this is because the energy is released. The energy is released when the sodium ion and chloride ion come together to form crystalline structure. The energy is so released to compensate the above deficiency of energy. So when they join, so the deficiency of this is also fulfilled, because when they join together like Na plus and Cl minus, when they make bond, so they also releases the energy which satisfy the 147 kilojoule mole inverse energy. Did you understand, guys?
Sir,
Explain
Yes.
again.
See, right now the deficiency of the energy is 147 kilojoule mole inverse. Yes. Okay. But when Na plus and Cl minus, when they make a join, they also releases the energy. So the deficiency of this energy, 147 kilojoule, when they release it fulfill and it becomes zero. Okay.
Sir, what do you mean by the So 147 kilojoules released by this Na.
No, it needs. Na needs 147 kilojoule. See, this is needs. We will write it as a minus. They release, we will write it as a plus. So right now minus plus, the answer is minus 47. Means this compound needs minus 47 kilojoule from outside the environment. Okay, means they needs energy,
Why?
because for formation of Na into Na plus ions is more as compared to chlorine minus ion. You can check the energy difference level. Here it is 496, here it is 349. Okay, so the difference is minus 147.
why
Now,
minus and not plus?
because they needs energy, minus 147 means they need energy. Okay, the minus
They need
represents
energy to
they need,
combine.
yeah. So this is minus and this is plus. So the answer will be in minus 147 because they needs energy. Now when Na plus and Cl minus, when they will combine, they also releases the energy. For example, if they will release 150 kilojoule, so this 150 and 147, it will nearly neutralize, and 3 kilojoule mole inverse energy will also release. Like this, it will happen. Okay, got it, guys?
So finally, this energy is released. So finally, 3 cold joule mole is released, right?
Yeah, 3 kilojoule. So it's like 150 is assumption. Okay, it may be more than or it may be lower than that. Okay, so this energy is so released that compensate the above deficiency of energy. You guys got this? No.
Sir,
Yes.
how come for Na it is minus 496 and for the chlorine it is.
Because Na needs energy to become Na plus 1.
But what about chlorine?
Chlorine releases the energy when he got electron. So when the energy is releases, considered as a plus. When energy is needed, considered as a minus.
Okay.
Got it?
But it's saying that electrostatic force of attraction. That means like since the cool I mean the force of sorry the force of attraction means that the force of attraction between positive charge and negative charge.
Yes.
Like K into big Q into small q divided by R square.
Yes.
And but R is distance, so then how is distance calculated between the two charges?
How distance is calculated between the two charges?
Like, is there a distance? Like, is the distance between the two charges long or short?
It is like that it won't be have the attraction force and it won't have repulsion force. It is like that. Like it is a place where the attraction force and repulsion force both will see. For example, this is an sodium atom. This is sodium atom and it has nucleus. Sodium has nucleus and this is the electrons of the sodium. And this is chlorine atom. Okay, it also have K shell, L shell. Now the sodium nucleus is there, which is I am representing as Na, and this is the sodium repulsion is there, which is I am representing as Nb. So the attraction force should be like this, so that minimum distance will be there. Because if they will come too close, then what will have? This have protons. This also have protons. They will repulse because positive charge will repulse. So they will have that much distance that the repulsion will be less and attraction will be less. So that it will become a stable position. So it is like that Adric, somebody is pulling you from right side and the equal amount of force is pulling you from the left side. So you are stable at one point. It's like that.
Okay, like here, both Na and Cl are charges. No, like here the Na is big Q and Cl is small q, and the distance between them is R, and K is 9 into 10 to power 9 uh, Newton meter square coulomb minute square, and from there you need to calculate the force, and that force is only the bond, right?
Uh, yes, I believe because how much charge is this? We are talking about the ions. So there is another formula for finding that. It's not this one, but if we will get like Na has how much charge and Cl has how much charge, then we can calculate with the help of that Coulomb's force formula.
Yeah, that formula what I was telling was Coulomb's law. That formula only.
Yeah. Okay. So now listen this. I'll read this. Okay, who will read? Agatha, can you read this?
David Agatha.
Yes, Agatha. Agatha, are you there? You're mute. Yeah, yeah. Hello, Agatha. I saw that. I'll tell.
Sir, look in the chat.
Yeah, I saw. Yeah, you read this. I'll tell. Oh, okay. I got it. Okay, Justin, can you read this?
You can see that each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions in its solid state structure. The force of attraction between sodium and chloride ions is uniformly felt in all directions. Thus, no particular sodium ion is bonded to a particular chloride ion. Hence, there is no species such as NaCl. Here, NaCl is empirical formula and shows that there is one Na plus for every Cl minus.
Okay, so 6 chloride ions are surrounded by 6 sodium ions. Okay, so the force of attraction between sodium and chloride ions is uniformly. Means it's not like that one place and this is the another place, and here it has more force of attraction and here it has less force of attraction. No, it's not like that. Okay, like every time, like this is, for example, this is Na and this is Cl, this is Cl, this is Cl, and this is Cl, this is Cl, and this is also Cl. So six, it is surrounded by 6 chloride ion, and every Cl ion is also surrounded by 6 sodium ion. Okay, so it's like that everywhere there is uniformly distribution of force. Okay, so in a crystal of NaCl, the 6 chlorine ion, which is surrounded by 6 sodium ion, or the 6 sodium ion is surrounded by the 6 chloride ion, they both will felt similar type of force of attraction. Got it? Because it's in symmetry. It's in symmetry. Got it?
Okay, but here the corners, no, in the corners, basically, only one, two, three of them, like the chloride ion is bonded to only 3 sodium ions, not 6 in the corners.
In the corners.
Ah.
Yeah, in the corners it's 1, 2, and 3. But each corner has same number of sodium ions. Like here it is also 3, here it is also 3, here it is also 3, and here is also 3. So each corner, like they have similarity. Similarity means symmetry.
And the edges,
Okay.
and in the edges it is 4.
Yeah,
But in the center one it is 6.
correct. Okay. So now we will, yesterday we did loose dot structure of NaCl. Today we will make a loose dot structure of MgCl2, which is magnesium chloride. Okay. Today we will do magnesium.
Sir,
Yes.
I don't know, did you answer this in okay. This morning I was having some problems getting in, so between the class I got out. So I don't know, did you teach this? So what are ions actually?
See, ions like Na, when the electron, they loses the electron, it become what? Na plus 1. Okay. So this Na plus 1 is called as ion. Now, because it has plus charge, it is called as cation. Got it?
So
If I will
ions
talk about,
actually form, so ions actually
your voice is breaking.
okay.
Say it again. Agatha, say it again.
So ions now is it clear?
Yeah.
So ions are made okay. So ions are made after an atom is releases or gains or gains electrons.
Yes. Correct.
Okay.
Okay. Okay. Now today we will make a magnesium chloride. Now everyone please pay attention. I will make it for you. Then you guys have to draw it. Okay. Listen, guys. Everyone please listen. Pens down. I have pens down. Okay. So now if I will talk about magnesium. So magnesium. So everyone learn the table. David, what is the atomic number of magnesium?
I only learned it till 10.
No, you have to
It's
learn till 20.
12.
Yes, David. David.
beta gata.
No, Adric. Yes, David.
12.
Yes. So magnesium, which is written by Mg, the atomic number is 12. If atomic number is 12, then number of electron is also 12. Okay. Now I will write the electronic configuration. So in K shell 2 will go, in L shell 8 will go, in M shell 2 will go. Understood? Yes or no? Okay. Now it has two options, to take 6 electron or to give 2 electron. Which one is easy for magnesium? To give 2
To give
electron.
electrons.
Correct. So it means that Mg will become Mg plus 2 when he will give 2 electron. Got it, guys? Yes or no? Yes or no? Any problem? Now chlorine. Chlorine has atomic number 17. So it means that number of electron is also 17. So in K shell 2 will go, in L shell 8 will go, in M shell 7 will go. So it has two options, to take 1 electron or to give 7 electron. Which one is easy for the chlorine? Unmute your mic and say
To gain 1 electron.
yes. So
To
what
gain 1
will
electron.
what it will be then? Chlorine will get 1 electron to become chlorine minus 1. Now the catch in this place is magnesium is ready to give how many electron? 2 electron. Yes, magnesium is ready to give how many electron? 2
2.
electron. But chlorine wants only 1 electron. Chlorine wants only 1 electron. Now in this case, what will happen? In this case, it will be magnesium has 2 electron and chlorine, or I will make it here. Magnesium has 2 electron to give, 1 electron and 2 electron. Okay, but chlorine only wants 1 electron, like this. So what chlorine will do? He will call his brother. He will call his brother. That brother, 1 electron you take, 1 electron I will take. Then we will become a family. So this will give this electron to this, and this electron will pass on to this. It's gonna be look like this. This will go and it will become this, and this will go, it will become this. So the final answer will be Mg plus 2 chlorine minus 1, in which 1 electron magnesium has, and the another one is also the bond of magnesium only. Why? Because he also received the 1 electron. Hence, the final will be Mg plus 2 Cl2 minus 2. Hence, the bond will be MgCl2. Got it, guys? So here one
And this will
chlorine
make
atom is not there.
magnesium chloride.
Chloride, yeah. Here one electron, one chlorine atom is not there. 2 chlorine atom is there. 2 electron they receive so that they can get 2 chloride minus 1 ion. Everyone got it? No.
Yes, sir.
Okay. David, Miraculin got it, beta?
Yes, sir. Yes, sir.
Okay. Quickly draw it. Then I will give one question based on this.
Should sir, I can't. Okay,
Yes.
no.
What
We should
happened?
draw the entire thing, right?
Yes, entire. Not MRF tire, entire. Sorry for the bad joke.
It's a good joke.
Quickly draw it. Adrik, did you understand better?
Yes, sir, beta.
Did you understand?
Yes, sir.
Perfect. I'm coming in 1 minute, everyone.
Yeah.
Got it, guys?
No.
Done, sir.
Done?
Wait.
Now you guys draw aluminium chloride.
Sir, are these the real steps we have to write during the exam?
Yes, these all steps you have to write. Not a single step you have to miss.
Done, sir.
Draw this aluminum chloride. Edric, draw this aluminum
Are
chloride.
you drawing the aluminium chloride?
Yeah.
I can't see it.
Here.
Okay, I can see the word aluminium chloride.
Yeah, that you have to draw it by your own.
Okay.
I drew it.
Aluminum chloride, you guys have to draw it. Edric, what are you doing, beta? Draw, na? You're not drawing?
I finished drawing for aluminum chloride also.
Aluminum chloride, you draw?
Yes.
Show me then.
I tried aluminum chloride first, then I drew aluminum chloride.
So you draw in your copy?
Yes, sir.
Oh, very good. So how you draw this? What is the first step you wrote?
So first I do the aluminium and then the chlorine, and then first the aluminium was it was 2,8,3 because the atomic number is 13, so it can fit 3 electrons in the outer shell, the M shell, and then it means if we can fit 3 in the M shell, the valency will be +3.
2, 8, 3. Very good. The valency will be
+3.
very good. Okay. Perfect. So aluminium will become aluminium +3 when he will lose 3 electron.
Yes, and then
Okay.
for chlorine it is 17, and then 2,8,7, and then number of electron is 17, and then for it will become Cl Cl plus E minus is equals to Cl minus 1. But you have to add 3 to all the sides.
So Cl will take 1 electron to become chlorine -1. Now, basically the catch in this concept is okay. So the catch in this is that chlorine -1. Here you can check that chlorine is getting only 1 electron. Okay, the chlorine is getting only 1 electron, but aluminium is ready to give 3 electron. So how many atoms of chlorine we need?
3.
3. So it will become 3 chlorine atom will take 3 chlorine, 3 electrons, will get 3 electron to get 3 chloride -1 ion. So aluminium, which has 3 electron, now
Oh.
3 chlorine atoms are there.
So can you explain the chlorine part again?
Chlorine part, what better? What you have to
When
understand?
the this why I added 3 in there.
Okay, so aluminium is ready to give how many electron, beta? You tell me. How to?
3.
3. So 3 and chlorine is taking only 1 electron.
Yeah.
If chlorine is taking only 1 electron, so they will not match, no? But chlorine only needs 1. Aluminium is ready to 3. So that's why chlorine will tell, brother, come. We will make a bond. 2 more chlorine atom will join their party.
Okay.
So that it become 3. Now 3 chlorine will take 1 electron each, become 3 electron is satisfied with the aluminium.
Okay.
Got it?
Yeah.
No. So here the 3 chlorine atom will take, and aluminium will get +3 charge, and the 3 chlorine atom will get -1 charge each. So it will become AlCl3. This is the aluminium chloride. Got it, guys? No, I didn't get anything. Yes, Ira, please ask me.
Yes, sir, I got it.
Oh, then it's good. Agatha, you got it, beta?
Yes, sir.
Miraculin, just Ron.
Yes, I got it. When I was doing, I was confused in the last part, like the
Yes,
the
which part?
the last part, like how the last part, like AlCl3, this one.
Okay. Now you got it or not?
Yeah, I got it.
Okay. Ira.
Okay, sir.
Okay,
What is the
so I
Lewis
hope
dot structure?
this is the Lewis dot structure.
It's just
Sorry,
called the Lewis dot structure.
give me a second. This is the Lewis dot structure. So for Lewis dot structure, we need to do these steps first. This is the first step, and then this is the second step. The whole will become the answer of Lewis dot structure. Got it? Edric, Tishron, Ira, got it? Yes or no?
Yes, sir.
Perfect. Okay. Perfect. Now we will read
Like 4 minutes break?
You want break?
Yes, sir.
Okay. So guys, you can take break. Come back in 3 minutes or 4 minutes. 3 minutes you can come.
Sir?
Yes.
Okay, so today, no, something like, you know what? Today is Pongal, right?
Today is Pongal, I believe.
Yeah. So you know what? Today morning, no,
Mhm.
my mom gave okay, like my mom forced me to eat like this Pongal, you know, like on Pongal day, like they give Pongal to
They give Pongal too.
like uh like you need to eat like you have to eat Pongal like rice, no, it like
So
Pongal is
it's it one different rice, no? It's not that rice, normal rice. I
yeah,
ate that rice.
yeah, it's a different rice, and there are so many types of Pongal, especially like that.
Yeah. chutney and small chutney and that pyra. No, that what is that name? Paya. No, what is that sweet?
That's payasam, but I didn't eat that.
Paisam.
Okay, so basically,
Paisam.
you know what happened today? Like, So first, my mom gave the first type of pongal, which is ven pongal. I ate that, and then my mom gave one small like idli, and then I ate. Then vada, then I ate. But the most important part of the pongal today morning was the chakra pongal. Sarkare pongal, and that is only the sweet pongal dish that everybody likes. And you know what? I hate it. And basically, that type of pongal, no, I hate it because it's too sweet and I don't like the taste of it. So, like next time when I see that, like when next year if pongal comes and when I see that chakre pongal, then I'm thinking of running away from the house, sir.
Mm.
I hate it.
Mm. Okay.
Oh.
I once like it was around Pongal only, or maybe some Onam or Pongal. We went to one Kerala hotel. Okay, so in that Kerala hotel, he was also a Keralite, so he made that Pongal for everyone. Those who become a customer, like they will have that Pongal. Okay. Now when we went, now I don't know that the sweet dish we will eat in the last.
Mhm.
Okay, the paisam should be like in Rajasthan. Whenever we go to weddings and all, so we have to eat sweet first, and then we will do the namkeen part like roti, sabji, and all the vegetables. So I don't know. So he stares at me like he will kill me because I ate that paisam first. Then one of my friends says that, oh, the sweet should be in the last, not in the first. But he made that dosa and many types of chutney. We ate on banana leaves and paisam. Not one paisam, two paisams was there. So yeah,
So
that was good.
basically today I didn't eat payasam. I ate another type of pongal. It's called chakrai pongal, and that is like rice only, a type of rice pongal, but it's sweeter than ven pongal.
Mm.
That only I had, and next time when I see that, I'm thinking of running away.
Okay, guys, come back, guys. Quickly come back. We'll start again.
Okay.
Okay. So now we were learning this that the oxide of two electrons are compared to the oxygen atom, hence it has negative charge. So magnesium oxide is basically which I give as a homework. It's there in that copy, so you can check this if you are making this. So we will now learn the properties of a ionic compound. So who will read? Ira, read this please.
Okay. Properties of ionic compounds. Since the ionic compound
Just give me a second. Yeah, read.
since the ionic compounds contain ions, cations, and anions, which are held together by the strong electrostatic forces of attraction, they show the following general characteristics properties. A physical state, ion, 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 ion,
Ionic.
ionic compound.
Ionic.
Ionic compounds are crystalline solids. In the crystal, the ions are arranged in regular fashion. The ionic compounds are hard and brittle in nature.
Yeah. So they are basically the crystalline solid type. Okay. They doesn't have the like they are crystal, you know, the salt, sugar, they all are basically made up of ionic compound. Got it?
Yes, sir.
Yes or no?
Yes, sir.
Hmm. Next part.
Melting and boiling points. Ionic compounds have high melting and boiling points. The melting point of sodium chloride is 1074 kilo
Kelvin.
Kelvin, 801 Celsius, and its boiling point is 1686 Kelvin, 1413 Celsius. The melting and boiling points of ionic compounds are high because the strong electrostatic forces of attraction present between the ions. Thus, it required a lot of thermal energy to overcome the forces of attraction. The thermal energy given to the ionic compounds is used to overcome the interonic attraction present between the
Interionic.
interionic attractions present between the cations and anions in an ionic
So they have very strong electrostatic force of attraction. So to break that, we needs lot of energy we require, because they have good store. Like for example, now I'll ask this question from Jashran. If somebody will help you in the time you were in need, so you will become a good friend, or you will become, yeah, just normal friend? You are very in need.
Good friend, sir.
Good friend, no? Good friend. So now chlorine needs that electron. Sodium is giving electron. They become very good friends. So it means that they will have very good bondage. And if somebody will try to break them, they require a lot of stress. They require a lot of energy, lot of thinking. Like if Jashron and Ira become very good friends, okay, so somebody has to, like, to break that bond. Somebody has to do a lot of work between them.
That means somebody has to do a lot of work between them means?
Means a lot of thinking they needs, how to make a Jashron enemy of Ira, like that they have to do.
Yeah.
Okay, so it's like that only. That how much thinking is basically the energy required to break the bond between the Na and Cl. Okay, so remember that the crystal has 3D regular cation and anion, which is called as crystal lattice. On heating, the breaking of crystal lattice lead to the molten state. Remember this thing. If you will heat iron like a namak, like NaCl, it will become a molten state. Molten state means like a lava. Got it? So it will lead to the molten state in which cation and anions are free to move. Free to move. Now, because they are in molten state, cation and anion can easily move. Hence, in the molten state only, they can conduct electricity or aqueous solution. Molten state means, just now we learned, aqueous solution means the adding of water. So when in water, for example, if it in water, if we will add this cation and anion, this Na plus and Cl minus, they both will again segregate. Hence, the NaCl will form. And see what will happen in the aqueous solution in the molten state. We will learn this. Okay. So for example, we have this thing. Okay. Now in this we have water. And we have two terminals. We have two terminals. One is cathode and another one is anode, which are joined with the battery like this. Okay. Now in this solution, we have solution of NaCl, means namak. I add the water salt into this water. Now what will happen when it is dissolved? Then it will break into the ions called as Na plus Cl minus. Na plus and Cl minus. Now what will happen? That the we know that the Cl minus have extra electron. Yes, that he got from the Na. So this Na plus will move towards the cathode and Cl minus will move towards the anode. Why? Because this anode is positively charged. What? Positively charged. And this cathode is negatively charged. This cathode is negatively charged. Now, what will happen? Because this is minus, it will move towards the anode. Because this is plus, it will move towards the cathode.
Because
So, what will happen? What
opposite
will
attack.
yeah opposite direction. So what will happen? The electron will move in this terminal, and the chlorine which have extra electron, when it will go to the anode, it will donate the chlorine electron to this anode part. Hence the extra electron that chlorine has, it will move like this.
And then the
Hence
current will flow
yeah,
opposite direction.
the circuit is formed, and when the circuit is formed, current will flow.
But current will flow in the opposite direction. Like you can use a red marker to make sure that the current flows in the opposite direction or something. Or positive.
Yes.
Sir,
Yeah.
so current can flow through water.
If water has some minerals or ions like this,
H plus
like
and OH.
there
Hydro
is one.
energy.
Huh?
So is this hydro energy?
Yeah, the hydro energy is different thing. Hydro energy is like this. When there is a dam, okay, so in that dam they make a wall like this.
There's like
Okay.
there's a wall, there's like a propeller type thing, and then when the water flows through that, the propeller gets turns around, and then energy is created with the magnets.
Yeah, perfect. So, like for example, there is a water inside this wall, like behind this wall. Now, when they will open the gates, there is a turbine. There is a turbine like this. So, when they open the gates, the water will come from this side, and the turbine will move. The turbine will move. The energy will be created. It is called as hydroelectricity. That is different. But we got that when a ionic compound is dissolved in water or in molten state, they forms ions, and because of that ions, the electricity will flow. Got it, guys? Turn on the
So
camera.
if
Hmm.
okay, so if ions are in their molten state, they become separate cations and anions. I don't know.
Yes.
Well, what was the pronunciation of them again? Those
Cations and anions.
cations and anions. And since cations and anions are separated, electricity can flow.
Yes. Correct. Got it?
Sir,
Yes.
the water has ions, H plus and OH.
Yes.
Because of that only, it is able to conduct electricity.
No, but distilled water, which also have H plus ions and OH minus ions, but still it will not conduct electricity because water itself will not conduct electricity. What if water minerals has there or some ions are there, then they will conduct electricity.
Only if it has ions, then only it will conduct electricity. If it doesn't have ions, it won't. But if it has
Yeah.
H plus and OH minus.
Yeah, but still it will not. Like distilled water I am talking about now. In distilled water, there is no minerals. Okay. So if there is no minerals, it won't conduct electricity.
Uh, so, uh, so, sir, what happens if you like drink distilled water? Will all the minerals go out from your body?
No, why? It won't. It's
I
like a
thought,
normal water.
I thought if you drink
It's
Distilled water.
It's distilled water like normal water, but like without any minerals.
Yeah, it will be tasteless. Like it won't have any taste. It's like that only. Okay, got it, everyone?
Yes.
Okay. So uh, we will read this. Who will read? David will read. Yes, David.
Uh, Electrical conductivity. Ionic compounds conduct electricity in their molten state and in aqueous solutions. Since
Hmm.
ions are free to move in the molten state, they can carry current from one electrode to another in a cell. Thus, ions
Hmm.
can conduct electricity in a molten state. However,
Hmm.
in solid state, such a movement of ions is not possible, as they occupy fixed positions in the crystal lattice.
Hmm.
Hence, in solid state, ionic compounds do not conduct electricity. In aqueous
Hmm.
solution, water is used as a solvent to dissolve ionic compounds. It weakens the electrostatic forces of attraction present among the ions. When these
Hmm.
forces are weakened, the ions become free to move, hence they can conduct electricity.
Okay. Okay. So give me a second.
Idea. Idea.
Okay. So this is the electric conductivity formula. You can check that the bulb will glow even though the wires are not joined. Why? Because the an ionic compound is there that will form cation and anion, and these form is responsible for the conductivity of electricity, hence the bulb will glow. Got it, guys? Yes or no? Okay. So we read this now. Solubility. Yes, this is important point.
Please
That
explain what you said again.
huh?
Can you please okay, you were saying that ionic compounds can only conduct electricity in their molten state, right?
Molten and aqueous state. Aqueous state means water added into it.
And what?
Water added into it. Water. Aqueous state is the state in which water is added.
So they
Okay.
can only conduct electricity in their aqueous state.
Aqueous state and molten state both.
Okay.
Both. In both state they will conduct electricity. Now solubility is they are soluble in water. They are soluble in water, but insoluble in organic solvent like alcohol, ether. Like if you will take alcohol and if you will dissolve salt into it, it won't dissolve. Okay, pure alcohol if you will take, it won't dissolve. Okay. This is your homework, guys. NaCl. Okay. Now covalent bonding. Okay. Covalent bonding we'll do tomorrow because today I have my headache. So covalent part we'll do it tomorrow. Tomorrow we'll understand the covalent bonding.
Sir,
Any problem till now? Yes.
solubility of ionic compounds means like sugar can dissolve in water. Is it like that? Something like that.
Yeah. This is also ionic compound.
Sir,
Yes.
the,
Yes.
sir, the whole in-text question 7.2 for homework.
If you guys have time, you can do it. Okay. As maximum, you can do it. Just do it.
Minimum, how much we should do? I mean, maximum.
It's upon you. You guys decide minimum and maximum.
But I mean, like, we have to at least do one question.
Oh no! Oh no! Oh no! Oh no!
Uno.
We have to at least do at least one question.
Do you have to do the activities for homework?
No, you don't need to.
Yes, I can hear you.
Hello, can you hear me?
Yes.
Yeah. So I was saying that as minimum you can do, as maximum you can do, it's all upon you. Okay. You just write homework. So we'll end this class. I hope you enjoyed the class. Till then, bye. Have a nice day.
Bye, sir. Thank
Bye,
you.
Bye,
sir.
sir. Bye, everyone.
Bye.
Bye, David Agatha.
Bye, Edric.
Edric,
And
stop.
David and